So I don't think that I should start from the very basics, right?
Yes, yes, yes.
So let's discuss about STP today.
Okay. Spanning tree protocol.
Yeah,
Yeah. Okay. So spanning tree protocol, it's a a loop prevention protocol
very
that
good.
is used between redundant path on the switch infrastructure.
Very good.
So yes, so that we don't have a loop on our network. A loop happens when a switch can send data through the network and the data gets to themselves again. So spanning tree helps us sort of like block redundant path so that we have a single flow of data.
Very good.
Yes.
Yeah, right. So, like you said, that one thing is very important in the network, and that is redundancy, right?
Yes, yes.
So if I build a topology like this, switch one, switch two, switch three. In this topology, STP is not required.
Yes.
Yes. But what is the problem with this topology?
You have a
The
single
problem
point
is the
of failure.
redundancy.
Yes.
If one of the link will goes down, or if one of the middle switch will goes down,
Yes. Everything is there. No
switch one
communication.
and switch two, switch three would not be able to reach to each other.
Each other. Yes.
And that's why we have a totally different approach in the network. We are following an architecture known as two-tier or three-tier architecture.
Okay. Yes.
So basically what we have in two-tier architecture, we have D1, distribution 1, we have distribution 2,
Huh?
we have access 1, we have access 2.
True. Yes.
1 second, man. Now we
Okay.
have switches and we have the redundancy, right?
Yes.
If I say if this link will goes down for an instance, so I have a backup link.
Yes.
If the links are up and D1 goes down, in that
Huh?
case I have the D2, right?
Yes.
So we do not have the scenario which is known as
Single point of failure.
single hop failure, right?
Yes.
Yeah, but for sure we cannot provide the redundancy of access layer switches. If this
Yes.
access layer switch will goes down, in that case,
We
one
need
of the
a
users would be out of station.
access.
You can say,
Yes.
right?
Yes.
But the benefit of doing this, benefit of following this architecture is that in case, for in the instance, if access one will goes down,
Hmm?
this network will remain intact, right?
Yes.
Not a problem in this side, the network.
Mhm.
That's the benefit of using this architecture.
Okay, checked it. Okay.
So, but the problem is once you add the redundant links, we know that we have two types of technology in the network. We have layer two technology and we have the layer three.
Yes.
So this is my distribution one, this is my distribution two.
Mhm.
This is my access one, this is my access two.
Yes.
I've connected all of them together. This is user one and this is user two.
Yeah.
IP address of this user is 10.1.1.1/24. IP address of this user is 10.1.1.2/24. For
Yes.
example, MAC address is A and MAC address is P.
Yes.
You know that first time PC1 will send an ARP request for PC2 if you want to send any traffic.
Yes.
And ARP request is always broadcast. So
Mhm.
destination MAC would be 12 times F.
Yes.
When the user will hand over this to the access one, what access one layer switch will do? Access layer
Mhm.
one switch will broadcast this frame by default. If I believe that STP is not there, right?
Yeah.
For a moment, if we think that STP is not there, So it means
Yes.
all of the interfaces are up, running, and in the forwarding state.
Yes.
So what switch 1 will do, switch 1 will forward this frame to D1 and D2.
Yes.
Then
Yes.
D1 has received a broadcast frame.
Mhm.
Will send this frame to this and this. Likewise,
Yes.
D2 has also received a frame. Will send this
Uh,
frame to this and this. Then
Yes.
A1 will send it to D2 to D1. Likewise,
Yes.
D2 to D1. Like this will create
A loop.
not a loop. It is an endless loop, right?
Endless loop. Okay.
Because that's the problem with layer 2 loops.
Mhm. They can
If for
go.
an instance we have a loop in layer 3 network,
Yeah.
that is known as defined loop, definitive, or you can say we have the value which is known as,
TTL.
for example, if you have a loop there, 255 will become 0 at once and the packet
Yeah.
will be discarded automatically.
Yeah.
We have a lifetime over there in the layer 3. That's why we don't require such thing like STP or any other protocol.
Okay.
So that's the problem here in layer 2 network. That's why what we have done, we have introduced STP,
Yes.
spanning tree protocol. So now the STP here. So what STP will do? STP came up with a very simple condition. STP said that okay, this is your topology, all right?
Yes.
Access 1, access 2. So what STP said? STP said that STP will block the redundant
Link.
links.
Mhm.
And we agree that okay, please do whatever, just give us a loop free topology. The STP said okay, let's see which port can be blocked, right?
Okay.
So you go to switch 1 and you ask switch 1 to please block your redundant port. Switch 1 said no, I'll not block my interfaces.
Mhm.
Then you have requested to switch 2 to do the same. Then access 1 and access 2. Nobody's
Yes.
agree on your right request.
Mhm.
That's why we are not asking them. But we said, okay, if you're not agree on me, do one thing. Let's decide a master switch.
Yeah.
Right. So let's do an election first.
Okay.
Why I'm getting so much many calls on weekend.
Okay.
Are there Kavasto?
Yes. I'm here.
Yeah. Okay. So every switch is designed to block their interfaces. So what we did, we said, okay, let's select a master switch, and the master switch will decide which interface will be in the blocking state, right?
Yes.
That master switch is known as
The root bridge.
the root bridge. So you know that how the root bridge is being elected, because you have to modify the root bridge election in the lab exam as well.
Yes.
It was only possible if you know that how the election process works, right?
Yes. Yes. So
So
it would
this,
look at the switch priority
yes,
or the root priority, which is made up of the bridge ID, which is the MAC address and the priority of the switch.
yeah. So election is done on the basis of bridge ID, which is 8 bytes of value, right?
8 byte.
Which
Okay.
we have 2 bytes, sorry, 6 bytes of base MAC address.
Okay.
We have 2 bytes of
Priority.
priority, which is also known as bridge priority.
Bridge priority. Yeah.
So you know that we can't fix this. It would
Yes.
be 6 bytes and we can't change the base MAC address. So the only
Yes.
thing which is left is bridge priority. That's why we have included the bridge priority in the election. By
Okay.
default, each and every switch is having priority 32768. 32768.
Mm-hmm.
32768 and 32768. So basically, the decision will be taken on the basis of base MAC.
Okay.
I'm just assuming, right,
Mm-hmm.
that MAC address is A, B, C, or D. But MAC address doesn't look like this. In MAC address, we have
Yes.
48 bits, or you can say 12 hex values.
Yes.
But you can see A is lower than any other MAC address. So that's why switch 1 will be elected as the.
The root bridge.
So, you know, right, that switch is STP is totally automatic protocol.
Yes.
STP is a completely automatic protocol. If you don't want to change anything, no need.
Okay.
STP will decide root bridge, STP will decide the block port, STP will decide the root port designated port automatically.
Yes.
But sometimes the final topology is not the desired topology. Sometimes we desire something else, right?
Yes.
That, for example, I don't want to be, say, switch 1 as the root base, or you can say access switch as the root base. So in that
Yes.
case, I want to manipulate the election, right?
Mm-hmm.
So if the decision is only taken on the basis of MAC address, I would not be able to manipulate this.
Yeah.
That's why what we did, we have added
Priority.
priority to it. So don't make the difference, because now the decision will be taken on the IP address, sorry, on the MAC address. But by
Mm-hmm.
changing the priority, you can manipulate the root bridge line, right?
Yes.
Yeah. That's why we come up with the idea of this priority.
Okay.
Likewise, I have also shown you the task in the lab exam, which have asked you to change the root bridge.
Okay.
You have seen in the last class, right?
Yes.
Bytes of base MAC and 2 bytes of bridge priority. This is the first thing we are going to elect
Yes.
now. So if I summarize STP, by default, STP is enabled on Cisco switches. STP will elect the root switch first, right?
Yes.
Once the root is elected, all other switches will elect a S4 to reach the root, and that interface is known as
Designated port. A root port.
root port. All right.
Yes.
STP switches communicate with each other using a message called
PPDU.
BPD, Bridge Protocol Data Unit.
Mm-hmm.
All switch ports will pass through some STP states: disabled, blocking,
Listening.
listening, learning, and
Forwarding.
not one thing, alternate never moves to learning state. If they can't move to learning state, they cannot come to the forwarding state, right?
Okay.
So see what happens. Then we elect the root base. Then all other switches will elect the designated port, root port, right?
Yeah.
And the port who is not being elected as root port or the designated port will become the alternate port.
Alternate port. Okay.
And that alternate port will, and all the elections will be done in the listening state, right?
Okay.
So if all the elections will be done in the listening state, now we have RP port, we have DP, and we have the alternate.
Okay.
DP will go back to the blocking state immediately, and only DP and RP port will move to learning state.
Yeah.
Okay.
Okay.
Only DP and RP will move to learning state. So alternate port never moves to learning state. As a result, it cannot move to forwarding state.
Yeah.
Right?
Yes.
Okay. Any the road port goes down on it, will automatically elect another
Root port.
root port. So a switch must have a root. Which switch? Non-root base. Okay.
Yes.
I can say a switch or a non-root.
Non-root switches.
Which cannot have
more than one root port. Okay.
one
Really? Okay.
So first selection is
Bridge.
root base election.
Port.
Done on the basis of
The bridge ID.
root base ID. So on the basis of base ID. Base MAC.
6 bytes.
6 bytes plus
Priority 2 bytes.
priority 2 bytes. Root port election. Right?
Yes.
Root port election. Must have
A similar root port. Per VLAN. Okay. Cost. Okay.
lowest cost to reach the root base, lowest center base ID, lowest center port ID, and
Lowest receiving port ID.
receiving port ID.
Yeah, can you just explain the lowest sender and lowest receiver in terms of the maybe in a diagram the two switches? Who's the
Lowest
sender?
what? Lowest center bridge ID or lowest center port ID?
Yes.
This one or this one?
Both of them, like the receiving and let's say in a architecture, who do we consider the sender? Who do we consider the receiver? So we have our master, maybe switch one, and then the other non-root switches. Who's the sender? Who's the receiver?
This is the topology.
Mm-hmm.
Bridge ID of this switch is 32768 plus A.
Yes.
Bridge ID of this switch is 32768 plus B. All right.
Yes.
Now, switch 1 will be elected as the root bridge.
Okay.
So if switch 1 is elected as the root bridge, it means switch 1 DPD is the best.
Yes.
So this port will become the DP, both of the
DP.
ports.
Yes.
And switch 1 will be sending a BPD to switch 2. Now, all the interfaces are having their default cost. So if you are
Yes.
using fast Ethernet interfaces, cost is 19.
Yes.
So now switch 1 is sending a BPD in which root bridge ID is 32768 plus
A.
sender is also switch 1,
Okay.
right?
Yes.
32768 plus port ID. Now port
Okay.
ID is 0/1 and 0/2.
Hmm?
0/1 and 0/.
2.
So port ID is combination of port number and priority, which is known as port priority.
Okay.
So switch 1 will be sending papers out of both interfaces.
Mm-hmm.
In this case, the only thing which is different is the port ID. Port ID.
Okay. Okay.
Now switch 2 will start comparing because switch 1 can only have a single root port, right?
Yes. Yes.
So now, first of all, switch 2 will compare. Okay, let's see which link is having the lowest cost to raise the root bridge.
Yeah.
You know what? There's a thing which is known as RPC, root path cost, which is by default 0 from the root bridge itself.
Okay.
But once the BPD is received on this interface, that cost will be added with the port cost. The total
Here.
cost is now
19.
0 plus 19, total cost is 9.
Yeah. 19.
You can
Yeah.
see both of the ports are having same
Equal.
cost,
Mm-hmm.
equal cost, right?
Yeah.
Now it will move to the next criteria.
Sender
Lowest
ID. Yeah.
center bridge ID. But you
Yeah.
can see the center bridge ID is also
The same. Yeah.
same.
Okay.
So it will go to the lowest sender port ID.
Port ID.
Now in
Okay.
this paper, it is 0/1 plus 128, 0 plus 2 plus 128. So priority is again same port priority, but the
Yeah.
port number is different. And port
Okay.
number cannot be the same in this case. So whoever the port who is receiving the lowest sender port ID will become the root port. So in this
Root
case, this port will become
the root port. Okay.
not on because it is 0/1. If I'll connect like this, if this is 0/1 and this is 0/,
Yeah.
still this port will become RP because what we are doing, we are looking the sender port ID, not the receiving port ID in this case.
Oh, at the top. Okay. Okay. Okay.
I'll show you when we'll say the lowest receiving port ID, but first we always see the
Port
lowest
ID.
sender port ID.
Okay.
So if it is 0/2, it doesn't mean that 0/1 will become RP because
Okay.
I'm not seeing the lowest receiving port ID. First, I'll see the lowest sender port ID.
Port ID. Okay.
Now, you will say in what cases sender bridge ID will be used,
The same.
right?
Yeah. Yeah.
So, for example, if I say I have 4 switches, switch 1, switch 2, switch 3, switch 4. You can select this. This is not a architecture. This is an ideal topology. Okay.
Okay. Okay.
So 32768 plus A, 32768 plus B, 32768 plus C, and 32768 plus D. All right.
Yeah.
Cost is
19.
so this time again switch 1 will become the root because of lowest base MAC.
Base MAC, yeah.
So now switch 1 will start sending the BPDUs out of this interface, in which root ID would be 32768 plus A, and sender will also 32768 plus
A.
right.
Yes.
Likewise, switch 1 will be sending BPDU to switch
2.
For switch 3, this port will become RP, because if switch 3Y go this way, total cost would be 57. From here, total cost is 90, right? For switch 2 is having two routes to reach the root base. Either it can go via this or it can go direct.
Yes.
Where is the lowest
Yes.
cost? This. So this port will
19.
become
A root port.
RP. Now, switch 2 will send this BPDU to switch 4. By
Yes.
sending the BPDU, root ID will remain same, 32768 plus A.
Yeah.
But the sender ID will be changed, because who is the sender this time?
It's switch 2.
Switch 2. So it would be 32768 plus B. From RPC, which is total cost. From switch 2, total cost is
19.
Then switch 3 will send the BPDU to switch 4. The root ID is same, right? 32768 plus A.
Yeah.
Sender 32768 plus C.
C.
RPC is 90.
90 also.
Now switch 4 will say, okay, from this port, 19 cost is coming, 19 of mine. Total cost is
38.
From this port, total cost is again
38.
So this is not the true. Then
Move
B,
to the low. Yeah.
lowest sender
Bridge ID.
bridge ID. On this port, the sender bridge ID is 32768 plus B. This switch port, the sender bridge ID is 32768 plus
C.
So this is the lowest
Bridge ID. Then put it.
B, right?
B. Yes.
So this port will become
The root port. Okay. Understood.
Now the last is very rarest situation. This one. Okay.
Yeah.
You won't be able to see this situation, but let me explain. In what cases we'll see this condition. So for example, I have a switch 1 here. All right. Then what I did, I've connected a hub in between. And then I have switch 2 here. This is my DP, because switch 1 is root base 32768 plus 8. 32768 plus. So this is DP 0/1, 0/2, 0/1, 0/2. Now switch, you know that hub is not having any operating system. So hub is not aware about any STP or this system. So now switch 1 will be sending 2 BPDUs. One from 0/1 and another one from 0/2. Now we have the hub in between. So but what hub will do? Hub will forward this BPDU received on this port out of this interface and
that interface.
This interface. So this interface has received this BPDU and this interface has received this BPDU. And hub will also forward this BPDU received on this interface to this switch port as well as
switch port.
See, here we have seen a different scenario. in which if this interface is sending the BPDU, this BPDU will not be received on this interface, right?
Yeah.
But this BPDU will not be received on this interface. So we can decide on the basis of sender port ID. But in case of this interface is receiving BPDUs, two BPDUs, one from
this one and the other one.
So it can't decide on the behalf of sender port ID.
Yeah.
So what switch will do in this case?
So look at the receiver's port ID.
Yeah, and this port will become ARP in this case. So this is just a, you can say, imagination. We are not going to build such topologies.
Yes.
All right. Okay. This is how STP will elect the root port. So we'll say then what is the designated port and how designated port is being elected. So let me tell you the difference basically.
Yes.
Root port. Okay. Designated port. DP port, right?
Yep.
So root port, the switch port, lowest, lowest, sender, right? Lowest,
Sender receiver port ID.
switch port, who transmit a best vehicle,
Okay.
right?
Yeah.
In terms of
Root path cost. Lowest sender bridge ID.
lowest, sender base ID,
Yeah.
lowest,
Port ID.
and lowest.
Receiving port ID.
Yeah, receiving port ID is being used.
Oh, yeah. Because we're
Port
transmitting now on the other side. Yes, yes, yes.
So
Okay.
the switch port who receives the best BPDU, the only difference is that who transmits the best BPDU. The designated port is the one who transmits the best BPDU, and root port is the one who is receiving the best BPDU. All right.
BPD. Yes.
Let me give you an example. This is my switch 1. This is switch. This is switch. All right.
Yes.
Switch 1. Switch 2. Switch 3. 32768 plus A. 32768 plus B.
Yeah.
And 32768 plus
C.
C. So switch 1 will become the root base, no doubt.
Yes.
Why switch 1 is elected as the root base? Because switch 1 is having the best base ID.
Base ID, yes.
So as a result, all of the interfaces will become
designated port.
Now, Switch 1 will send a BPD to Switch 2. Switch 1 will also send a BPD to Switch 3.
Yeah.
Cost is 19, 19, and 19. So Switch 2 will say, from this path, I have total 38 cost. By this, I have 19, right?
Yeah.
Likewise, from this path, I have 38 cost, and direct I have 19.
19.
So both of the switches will decide their root port.
Yeah.
Switch will say my root port is this, and my root port is
that one.
Now the question is, who will transmit BPD on this switch port? Because in case of STP, either you can send a BPD or you can receive a BPD. A BPD doesn't flow in both directions. Okay.
Yeah.
Like in this case, if DP is sending, RP is receiving. So who will send the BPD on this link? So we have to decide the DP port, right?
Yes.
Now, switch 1, switch 2 will say that root is 32768 plus A.
Yeah.
Sender is
plus B.
And RPC is 19.
Yes.
Switch 3 will say, okay, root is
that plus A.
Sender is
plus C.
Sorry, plus
yes.
C.
Yes.
And RPC is 19. So 19, now, switch 2. So who transmit the best BPD? Lowest?
Yeah, it's switch 2. Both
of the switches are sending the same root bridge ID, right?
Yes, yes, yes.
It means nobody is having the lowest root bridge ID in this net. Then lowest
sender
lowest root path cost.
Yeah.
Now the root bridge is located at the exact same cost from both the switches. From switch 2 cost is 19, from switch 3 cost is
19.
10.
Yeah.
Lowest
sender bridge ID.
So now in this case, switch 2 is having the lowest sender
bridge ID.
So what will happen here? Port of switch 2 will become the designated port.
Yes.
This will become the designated port, and this port will become alternate port, because this port doesn't become the RP or DP. So a port who doesn't become RP or DP will become alternate port. So now we have STP states here.
Yeah.
First of all interfaces are in down state, so STP is disabled. And blocking, then listening,
learning, and forward.
So first time if ports are in the down state, it means STP is in the disabled state. When the port will enabled, all interfaces will pass through blocking state once, then they will immediately come to the listening state. In listening state, root bridge, root port, DP and alternate elections will happen. Okay.
Okay.
In this case, all the elections will occur. All right. So in this case, by default, all the interfaces will remain in 15 seconds. In which state? Listening state.
Yeah.
It will take around 15 seconds, all right, to move to the learning state. But always remember, only DP and RP will move to
forwarding state.
Sorry,
learning state. Learning state. Yes.
Alternate port will go back to
block.
Then from learning to forwarding, again it will take
15 seconds.
So this timer is known as
delay time. Okay.
Forward delay timer, which is 15 seconds. So total it will take around
30 seconds.
At the time of like in 20th century. Okay.
Okay.
But now we are in 21st century. And this is not acceptable that the topology will take around 30 seconds to
Reconfig, yes.
write.
Mhm.
So that's why you know that we have multiple STP types
Yes.
with improvements, right?
Yeah.
So we have STP types. The first STP type was CST, common spanning.
Common spanning tree.
Now, what was the problem? Problem is
That's a bit slow.
yes. Problem is single STP
Instant. Okay.
role
VLANs.
is not
Okay.
supported because you'll have a single loop rate topology.
Yes.
Role
No VLANs.
less overhead on switch. Yeah, the benefit is that less overhead on the switch. But the issue
Yes.
is that load balancing is not supported. And
Slow convergence.
normally it takes 30 seconds. Right?
Yes.
It can go to
50 seconds. So,
in case of
okay.
if any failure occurs, it can go up to 50 seconds as well in case of reconversions. All right.
Yes.
So we have the benefits of running CST because in case of CST, we have only one DPU. It reduces the overall load on the switch. The
Okay.
problem is we would not be able to achieve the load balancing, right?
Yes.
So if I have this topology, this is my D1, this is my D2, this is my access 1, this is my access,
True.
and we have two VLANs, for example, 10, 20, 10, 20. So in case of CST, VLANs have no identity. So only switch 1 will become the root base, right?
Yes.
DP, DP, DP. This port will become RP, RP, DP, alternate, RP, DP, and alternate.
Alternate.
So
Okay.
this is the physical topology, and STP will convert it to a logical topology.
Okay.
If I say D1, D2, A1, A2. For an instance, I can remove the redundant links, right?
Yeah. Yeah.
This is the topology, final topology. Is there any chances
Yes.
of loop,
No.
right?
No chance of it. Yeah.
So this is done by STP. But the
STP.
problem
Okay.
is I would not be able to utilize all of these links.
Yes.
They are only for the redundancy, not for the load balancing.
Okay.
But yeah, it's good at that time because that time we don't have much traffic.
Yeah.
But nowadays, this is not a desired solution. And you'll see in coming 5 years, or not in coming 5 years, in you can say in 2 to 3 years,
Yeah.
you'll say STP is completely removed
Okay.
because we are moving to SDF.
SDF.
And in
Okay.
LAN, we are moving to SD Access Fabric.
Mhm.
So SD Access Fabric is not using
STP.
STP.
Yeah.
Okay.
Yes.
Yeah. So then again, it is an open standard protocol.
Mhm.
You can say IEEE standard. Then the second protocol is then Cisco said, okay, let me do something for you. So Cisco designed PVST
Heavy.
or VLAN spanning tree.
Spanning tree. Mhm.
PVST protocol. Sorry. Only plus. The second protocol is PVST, right?
Yes.
It stands for per VLAN spanning tree. So first thing first, PVST is a Cisco proprietary protocol.
Yes.
Number of instances is equal to number of VLANs, right?
Mhm.
Per VLAN BPD.
Yeah.
Multiple loop-free topologies. So you can say load balancing is supported, right?
Okay.
But
Yes.
again, the problem is
Slow convergence.
slow convergence. So if I say that I have again, this is my switch 1, this is my switch 2. This is my access 1, this is my access 2. So we have two users here. This user is in VLAN 10 and this user is in VLAN
20.
20. So what I did, I've configured D1 as the root base for VLAN 10. All right. And I've configured D2 as root for VLAN 20.
20.
So for VLAN 10, this port will become DP, DP, and DP. This
Yeah.
port will become RP for VLAN 10.
Yes.
And this port will become RP for VLAN 10. This port will
Mhm.
become alternate.
Okay.
RP, DP, DP, and
Alternate.
alternate. For which VLAN? 10.
Only VLAN 10. Yes.
Right? For VLAN 10.
Mhm.
Because for VLAN 10, who is the root base? Switch 1 or D1.
Switch 1.
Now for VLAN 20, this port will become RP because switch 2 is the root base. Sorry,
Yeah.
DP, not RP. For VLAN 20, right?
Yeah.
This port will become RP for VLAN 20. This port will become DP for 20. This port will also become DP for 20.
Mhm.
Now this port will become RP. For which VLAN?
Yes. For 20.
This port will become alternate.
Alternate. Mhm.
This port will also become alternate for VLAN 20 and this port will become
RP.
RP and DP. So now in this case, I have two loop-free topologies, D1, D2. Sorry, A1,
Yes.
D2 and A2. Sorry. This is the loop-free topology for VLAN 10.
Yes.
And for VLAN 20, day 1, day 2, A1, A2.
Right.
This is the loop-free topology for VLAN 20. All right.
Yeah.
So this is how PVSC offers you the load balancing. At the same time, you can forward the data out of all interfaces.
Yes.
More BPDU, more VLANs means more,
PPDU.
which increase
Switch
load
processes.
on the switch,
Yeah.
right?
Yes.
But yes, we have to do it because we cannot compromise the load balancing. We can give more power to switch, right? But we cannot compromise on the load balancing. We
Load
need
balance.
load balancing at any cost.
Yes.
But then PVST, along with the PVST, Cisco also introduced PVST Plus.
Yes.
PVST Plus, you can say, is an enhanced version of PVST, right?
PVST. Yeah.
Because the problem was PVST was not compatible with
Other vendors.
CS. That's why Cisco come up with PVST Plus. So PVST Plus is the replacement of PVST.
Okay.
Nowadays, you won't be able to see PVST on Cisco switches. You'll see PVST Plus in the operation.
Okay.
But again, the problem is
Slow convergence. Okay.
So we come up with the idea of
Rapid.
So first, we come up with a protocol which was, you can say, RSTP, Rapid Spanning Tree Protocol, RSTP. All right. It is an
Open standard.
single STP instance, single BPDU for all VLANs, right?
Okay.
Faster conversion.
Convergence. Okay.
Load balancing is not
Supported.
So basically, this was the problem with
Rapid
RSTP. So Cisco did what? Cisco introduced a very similar protocol. Its name was
Rapid per VLAN.
Rapid PVST Plus.
Okay.
All right.
Yeah.
The difference is Cisco.
Okay.
Per VLAN STP.
Yes.
Per VLAN
PPDU.
and faster conversions as well as load balancing is
Supported. Okay.
supported. So you know what? At the time of RSTP or RPVST Plus, what changes has been done in the STP. So if you say in traditional STP, All right.
Yeah.
We have hello timer. You can say which is 2 seconds. BPD timer. We have
For
forward delay
delay,
timer, which
30
is
seconds, 15 seconds,
maxis timer, which was
20 seconds.
in all the rapid STPs. We have hello again. This is
2 seconds.
still 2 seconds. 0 seconds.
Mhm.
Maxis timer is
6 seconds.
right.
Okay. Yeah.
First change is this. So timers has been modified. Second.
Yeah.
Traditional STP port states. Disabled.
Blocking.
Blocking. Learning.
Listening. Listening first before learning.
Yeah. Sorry. Listening and learning.
Yeah.
All right.
Yes.
You can say rapid.
Yes.
In rapid STP, we don't have listening, learning, or like this. We have
Discarding.
so all right, and learning and
Forward.
forward.
Okay. So the election happens on the discarding.
Yeah.
Okay.
Basically, there is election are totally different. In normal STP, this is switch 1, this is switch 2. All right.
Mhm.
32768 plus A, 32768 plus B. Switch 1 will send BPD to switch 2 at first time. Switch 2 will also send BPD to switch 1 in order to participate in root based election. Okay.
Yes.
Now, switch 1 BPD is best, right?
Yes.
So switch 2 will stop sending the BPDs now. Switch 2 will say, okay, switch 1 is the root bridge, so this port is RP and this port will become DP.
CP. Yeah.
Only switch 1 will be sending the BPDs now,
Okay.
right?
Yeah.
Now, you know what is the problem here? Basically, the problem is switch 2 will not inform to the switch 1 that you are root bridge for me. That you are root bridge for me. So, you know, switch 1 is dependent on the timers to move to next state.
Yes.
Because we have a very big topology, and what we want to come in the forwarding state at the same time.
Yes.
So that's why switch 1 will be in the waiting state. So switch 1 will say, okay, now we are in listening state, then we'll move to learning state, and then we'll move to forwarding state. But in case of rapid STPs, this is switch 1, this is switch
2.
We have a BPD, but in BPD we have a special flag which is known as proposal and agreement.
Okay.
32768 plus A, 32768 plus B.
B.
Switch 1 will send a proposal. See, it's a BPD, all right? Proposal is just a flag. Proposal is just a flag inside the BPD. So switch 1 will say 32768 plus A, switch 2 will say 32768 plus B.
Okay.
Who is having the best BPD?
Switch A. Switch 1.
Switch A, right? So
Yeah.
switch 2 will say what? Switch 2 will say, okay, this port is become RP, and switch 2 will send an
Agreement.
that I will acted my port as RP, and
Okay.
I'm moving my port to
Forwarding. Okay.
So this time switch 1 will not be waiting for timers, right? Switch will say, okay,
Okay.
my this port is DP and I'm also moving it to.
Forwarding.
So in this case, STP election is not interactive election, right?
Yeah.
They are not interactive with each other. But in this case, you can see STP election is
Interactive.
if you think that the switch is root base for you, you should tell the switch that you are the root base, right?
Yeah.
So now you are not dependent on the timers to move from one state to next state.
Yes.
Yeah. Done. Hello.
Yes.
Clear? This is clear.
Yes.
All right. So that's why RSTP or all of these protocols are rapid in the convergence, right? Few other changes has been also made and done to the protocols, like we have two post calculation methods,
Yes.
right? We have the short method and we have the
Long method.
long method. In short method, the post is a 16 bits long value. Long method, the cost is a
32-bit.
32 bits long
Yes.
value. So like I've shown in the last class, let me show you it again.
Yes.
STP task. Where is STP? Read the fourth task.
Fourth task. Okay. Under three switches, perform cost calculation in 32-bit arithmetic. Yes.
So you have to enable STP version who calculates metric in 32 bits format, right?
Okay. Yeah.
So in this case now what we can do, we can see, okay, we have options, right?
Yeah.
We have option CST, PVST, PVST plus, RSTP, RPVST plus, and MST. Now I know that
Yes.
these protocols
Are out.
doesn't support 32 bits arithmetic.
Mhm.
So now we have 3 protocols left.
Yeah.
I can't run STP on Cisco devices because it is an open standard protocol. Now I have
Okay.
only 2 options left, right?
Yes.
So here it is talking about the VLANs, not about the instances.
Mm-hmm.
Because in an STP, MSTP, we have instances.
Instances, yes.
It means we have to enable
Pavilion.
RPVST plus, right?
Yes.
That's why we have to
Long method.
focus on this thing.
Okay.
Yes. So now come back to this. So we have 2 methods, short method and long
Long
method.
method.
In long method, we have 32 bits metric. In short method, we have 16 bits long
Metric.
metric. They can also ask you to manipulate the root port.
Mm-hmm.
So for root port manipulation, you can change the
Cost.
STP port cost
Mm-hmm.
or STP port
Priority.
priority. For example, if they have given you a task like this is switch 1, this is switch 2. Three two seven six eight plus A,
Yes.
and 32768 plus B. So
Mm-hmm.
switch 1 will become DP, right?
Yes.
This is 0/1, this is 0/2, this is 0/1, this is 0/2. So this port will become RP because of lowest sender port ID.
Yes.
This port will become
Alternate.
alternate. Now the condition is on switch 2.
Yeah.
0/2 must become the
Old port.
only allowed to make changes on.
Switch to.
It is very easy for me. You know what I'll do? I'll go to either 0/1, I'll increase the cost, or I'll go to 0/1, I'll decrement the cost. So by default, cost is 19.
Mm-hmm.
So I go to 0/1 and I said STP cost is
100.
so this
Okay.
port will become
The root port.
RP and this port will become alternate.
Yeah.
What can be the other condition? The condition is on switch 2, who must become the root port? 0/2.
Okay.
You are not allowed to make any changes on switch 2 itself.
Okay.
What you will be doing in this case?
On
Now
switch.
you have to change the port ID.
Mm-hmm.
This port ID. Port ID is a combination of 2 values.
Mm-hmm.
Okay. First value is port cost.
Mm-hmm.
Second value is port. Sorry, not port cost. Port priority.
Yes.
Second thing is port
Number.
by default 128. So for this 128 plus 0/1, and for this 128 plus 0/2.
2.
And you know that
Yeah.
Lower is
better.
So you know that you cannot change the port number. If this is 0/2, it would be 0/2.
Yeah.
So only thing we can change is port priority, because the condition is like this. You are not allowed to make any changes on switch 2 itself. So it means
Yes.
only switch 1 where you can make the changes.
Yes.
So I'll go to switch 1. I'll go to switch 1 and I'll go to this interface. I'll change the priority to less than 128. I'll make it 112.
Okay.
So this port will become
RP.
all right. Any confusion here?
No confusion. It's very clear.
All right, and it's very clear. So, okay. This kind of task will be given in the lab itself. All right.
Okay.
So now we have done with the rapid STP and we have done with the rapid PVST. So our PVST will increase the load, right?
Yep.
You know what is the problem here? Problem is
Switch process.
more number of PPUs means
Load on the switch.
CPU, right?
Mm-hmm.
And more number of BPUs doesn't mean more number of loop-free topology. See, this is switch 1, this is switch 2, this is switch 3, and this is switch 4. Now I have 4 VLANs. All right,
Yes.
10, 20, 30, 40, 10, 20, 30, 40. And as you know, access layer switches should not be elected as the root bridge.
Yes.
So only option is distribution layer switches. Now I have 4 VLANs. I am running RPVST. So each switch will be sending 4 BPDs. If I'll configure switch 1 as the root for VLAN 10, right?
Yeah.
So this would be the topology: switch 1, switch 2, switch 3, switch 4. This port will become like this, right?
Yes.
Because other ports will remain in blocking state. For example, if I'll configure switch 2 as root bridge for VLAN 20, then what would be the topology? Switch 1, switch 2, switch 3, and
Which one?
sorry. This is the topology for VLAN.
Yeah.
Now tell me, for VLAN 30, who is the root base? Switch 1 again, because I cannot configure switch 3 and 4 as root base for any VLAN because they are access layer switches. So again, for VLAN 10, what is the loop free topology?
Switch 1.
Same as VLAN 10.
Yeah.
And for VLAN 20, again, sorry, for VLAN 4.
40. Yeah.
Switch 1. So you'll see at the end of the day, you will end up having the same topology for VLANs.
Yeah.
So it doesn't make sense to send BPD for each and every VLAN separately, because at the end of the day, you will be having very limited number of switches as root bridge. So we'll have very limited number of loop-free topologies. Yes or no?
Yes. Yeah. So
what is the solution, right?
to maybe no need to reinvent the wheel. Maybe just put a certain VLANs into one instance and
Yes.
the other VLANs in another instance.
This is what MSTP did.
Yeah.
Second problem is I was having a 3750 series switch in the rack, right?
Yes. Yes.
So what I did, this is my switch 1, this is my switch 2. So I have a link between them which was configured as trunk. So I have configured VLAN from 1 to 200 on switch this and 1 to 100 on this switch. Now by default STP is enabled and all the VLANs are active on trunk. That switch gave me an error.
Oh.
Switch 1 cannot run more than 128 STP instances because of lack of
Resources, yeah.
available. So I would not be able to prevent loops for VLAN 129 to 200.
Okay.
Because now switch is sending 128 BPDs in average 2 seconds. So see, two things are increasing. First, load on the switch. Second, load on the links. In every 2 seconds, you are sending 128 BPDs on a switch port. So the bandwidth will be consumed by that that BPD, right?
Yes.
So that's the problem. So that's why we come up with the MSTP, multiple spanning tree protocol. Now what MSTP is doing here, if I take the same scenario which we have discussed here, instead of doing this, what I can do, I can create two instances. Instance 1, VLAN 10 and 20. Instance 2, 30 and
30. 140.
right?
Yes.
For instance 1, I'll configure this switch as root. And for instance 2, I'll configure this switch as
the root.
right?
Yes.
And in case of MSTP, we have a single BPDU. Okay.
Okay.
That's the benefit of configuring MSTP. Now you'll say, okay, so if we write down the properties of MSTP, MSTP 1, 2, 3, 4, 5. Okay. So fifth, multiple spanning tree protocol, MSTP.
Yes.
Cisco proprietary protocol. Supports load balancing, rapid convergence, less number of PPUs. You can control the number of STP instances. You can control the number of STP
Instances.
instances. If you have 100 VLANs, it doesn't mean that you will be having 100 STP instances.
Yeah.
By default, all VLANs are mapped to an instance known as
Instance 0.
if you enable MSTP on a switch, by default there is an instance which is known as instance 0.
Okay.
Right?
Yeah.
So all the VLANs are mapped to instance 0 by default, but you can create instances as per your requirement.
Okay.
Yeah. All right. So that's a quick revision of STP.
Okay. MSTP.
If you have any confusion in this, please feel free to ask.
No, it's very, very clear. It was a good refresher for me.
Yeah.
Yes.
So I think that's enough for today.
Okay, sir.
I can share this MS Pin file if you need.
Yes, please share. And yesterday, remember you were supposed to send me the thing
syllabus,
again.
right?
Yes, yes.
Sorry, I forgot. I'll send it today.
Yeah, please share everything and then we can move forward. Okay.
I'll share it now. Okay, right away.
Okay. Okay, thank you, sir.
It was nice connecting with you. I hope you enjoyed the lesson.
Yes. So so for next week, are you coming back or is it somebody else?
No, me.
Okay. Let me check the date for next week because we're going to have Christmas. So
Okay.
today
Yeah, it's Christmas.
is the 18th. Yeah. So let me check today. Today is the 18th.
Yeah, it's Christmas, and on 25th and 24th is Saturday.
Saturday. Okay.
Yeah.
Okay. So